Hello, welcome all. In this hackathon competition announced by TigerGraph Graph-based solutions product, we would like to introduce a new solution, optimal location search based on graph. In real world, when people search for properties, either for rental or for purchasing, they go and look at the various websites and they enter the locations one by one and get a list of locations, results that belong to any one of these three locations. If you enter three locations, you will get the locations that are belonging to the three postal codes that you enter or the three city names that you enter. On the other hand, in real world, what people need is a lot more optimal solution than that. The family looks for a rental property or a real estate property for buying. It has a need to go to multiple destinations every day. The kids have to go to the school or college. The mom has to go to office. The dad has to go to office. So what the family actually needs is a list of destinations, okay, where they will visit every day and come back home. So it is sufficient if they enter the list of destinations they will frequently visit in the order of priority. And then they click on the search button. And now the search engine, what you should do is to find out an optimal postal location code that is well connected by public transport to the two or three entered destinations to which they will frequently visit and come in the list. So you might get results that have a postal code which may not be even there in the original list. However, this solves a problem completely in a different way. In this proof of concept, what we are doing is essentially we are getting three vertexes. What are those vertexes? We will see now. First, we will have a look at the schema. We have the location that's the vertex and goes to the another location. Right now, that would be the edge. Okay, and this is the results that we have. And what we are doing is essentially we are picking up the first location, second location, third locations, and in the order of priorities, right? We are just trying to arrive at the list of locations that are connected to the first location entered, second location entered, third location entered, and finally we intersect the results. Okay, and using this intersection concept, right, we will be able to arrive at the optimal locations, right, which are closer to the original ones entered. In this case, we have entered 357 and we also get 246. And from this, we will be able to make out right now. It could be 4 or it could be 6. Now that is actually an optimal solution. By looking at the result in a tabular format. And since this is a POC, we have just shown you how the coding can be done with the TigerGraph very easily with the GSQL. And not only that, right now we can create the vertex and edges very easily and be in a position to run the query, create the development, do the development, and there are plenty of optimizations that can be used besides the regular GSQL. And how you can see the results optimally in tabular format in case if you want to, or if you want to see in the JSON format, or if you want to see in the graph format. Now, this approach can be extended to be integrated with the rest of the real estate properties. It's something similar to what we have here. This is the other application that we have. And what they have done is essentially right now figure out a meeting center of gravity for zip codes. So you can enter the zip codes of various locations and click on the center of gravity, and that will let you know what would be the best place for you to visit for a number of people coming from different locations. What would be the optimal location? And this is exactly what we want to try. How we need to solve the problem for rental and real estate property search as well. The current search based on the relational world doesn't help you either. However, a graph-based search for rental and real estate properties, particularly using TigerGraph, can be a rock solid super hit. That is something that is badly needed, and however, technically not well understood or appropriately understood by the technical community. So with this approach, right, we will be able to resolve the problem better, more easily.